Hello class, we're here for our final video. So that's been encouraging. Thank you for being so diligent throughout this last 7-8 weeks. Today we're going to do just a final review. There's no assignment for today, but it gives us some details for the upcoming final. There'll be 33 problems on the test. Some will be short answer, some will be word problems. Okay? This part is significant, I think. Every question on the test does come under at least one of the bullets on this review. Okay, I got more than 33 bullets. Not every bullet on the review will have a corresponding question, but every question that will be on the exam will be covered under some bullet on this review. So just keep that in mind. And again, I can't do every last bullet for a question just because it would make your final too long. So I'm trying to pick what I would think are some of the main concepts that I would like to hit on the final. Here's some good news. For some of you, I know that this is a concern. Calculators will be allowed. Calculators will be allowed throughout the final. Now, just like we did in the last test, you'll need to bring a clean piece of paper or pieces of paper to put your answers and your work. Just please put them in order, nice and clear, and then take a picture and put them in the corresponding drop box for the final. You'll have 2 hours to take and turn it in. Again, I won't be there to remind you that there's 5 minutes left or 10 minutes left, so you kind of have to have a watch or something close by so that you can keep track of the time. If you turn it in after the 2 hours, you'll get a deduction because I can tell when it's been turned in. So this is kind of your responsibility here to know the time that you're involved. 33 problems, that's probably 3.5 minutes per problem, something like that. The exam is scheduled for next Thursday, May 7th. Notice the time changed, 12:30 to 2:30. Maybe that hasn't been changed. I know for some of them it has, but double check the time that you anticipated. This is the time for the scheduled exam. They were all changed a little bit. You won't be allowed access to the exam until that starting time, so you'll be able to load it or download it. I'll also be sending you an email right at that 12:30 mark in case you can't download it from there. Here's the good news, no class this Friday. No class this coming Friday, okay? So those are some details. Again, you may freeze your computer right now and copy those down if you want, because it'll be a while before you actually take the exam. It's way on the Thursday. It's one of the last exam periods out there. So it'll be a while, okay? Now we're gonna cover some concepts to prepare us for the exam. First of all, we have sets of numbers. I think it's pretty important for us as math teachers, whether we're teaching at first, second grade or third, fourth grade or 7th or 8th grade, to know how the numbers are built on top of each other. We finished looking at imaginary numbers in our last chapter 9. Before that, we had real numbers, but these two together make up the complex numbers. Remember, this real numbers has an entire set of numbers it's built on. It started with natural, then went to whole, then to integers, then to rationals, then to irrationals, and finally to reals. So all of these are in that real number category. There's a lot of different sets in there. We should be able to know exactly what numbers are in each set. If I give you a number, say a -3/4, I could ask you to tell me what sets of numbers contain a -3/4. Or if I were to give you 5 radical 3, you should be able to tell me what sets of numbers contain 5 radical 3. If I have 5 radical 3i, you should be able to tell me what sets of numbers are in those. So all of these different sets of numbers, we need to have a pretty good handle of what they're about. Next, an important concept is order of operations. This is again something that we agree upon worldwide when we're simplifying mathematical expressions. Our first priority would be to remove the exponents or take care of the exponents. Second one is the grouping symbols. Keep in mind the division bar is technically a grouping symbol. What do I mean by that? If that means I have 3 plus 2 divided by 6, that really stands for 3 plus 2 in parentheses divided by 6. The division bar implies the parentheses is there. So any grouping symbol is the second priority. Then we do the multiplication from left to right and division from left to right, and we finish with addition and subtraction. I know you've seen these before, but it's maybe been a couple of months since we did them. Here would be an example of a problem like that. Here's an exponent, that would be a first priority. So I would change that to 16. Next, all the grouping symbols. So this would be changed to a 3, this would be a 6. This is a grouping symbol, it's implied there. So that division would be a grouping symbol, would be 4. So I would change that to 4. Then I'm going to multiply from left to right. So it would be 3 times 16 divided by 8 minus 16 plus 10 plus 4. And then I would finally do the addition and subtraction. So there's an order to be followed there. We looked at prime versus composite numbers. And the main reason that we talk about prime versus composite numbers is when we're dealing with fractions, we need to understand the difference between the two. For example, reducing a fraction down means I am going to have comparable primes, numerator and denominator. Composite numbers are also multiples of something. So oftentimes when we have to go common denominators, we're talking about in composite numbers. So prime versus composite are pretty important when it comes to fractions. We also should be able to transform percentages to decimals to fractions. For example, you should be able to go 30% is equal to 0.3, which would be 3/10. I should be able to give you any decimal and you could give me the corresponding percentages or fractions, or I can give you a fraction, you should be able to give me the decimal in percent, etc. We had a bunch of different types of equations with percentages. Here's one example, 30% of what number is 12. Now this is not the only type, there's 2 or 3 different types that we had, but these are an example of what I'm referring to. And these are pretty important, so likely anticipate some of those. We also had operations for fractions. We had addition like I'm doing here, subtraction like I'm doing there, multiplication like I'm doing here, and division like I'm doing there. You should remember that when I add and subtract, I need a common denominator. I do not need common denominators when I multiply or divide. And again, there's a significant difference in how we approach those. We certainly should be very familiar with any of those 4. One of the common problems is percentages involving or in word problems and percent of change, past and present. I think this percent of change, past and present, is maybe the most frequently missed percentage problem. Because it's missed so often, I've tried to give an example here of the two, all right? If you have a current wage of $15 this year, this would be wage per hour, and you are scheduled to get a 20% raise, what will your wage be next year? Well, that means I would take 20% of 15 and add it to 15. Most students would get this one correct. It's the past that gets a lot of people. Here's an example. If you have a $15 wage this year, which was a 20% raise from last year, what was last year's wage? Well, keep in mind, what that means is I should be able to take last year's wage add to it 20% of last year's wage, And that should give me this year's wage. This is last year's wage plus the raise equaled $15. Well, this is really a 1 plus 0.2. It really turns out to be 1.2 times last year's wage, which we could call an X. But that means I'm going to be taking last year's wage, and it's going to be 15 divided by 1.2. And that gives us $12.50. That's the correct answer. A lot of people would get 12. What did they do? They took 20% of 15 and subtracted it off. But when you get a 20% raise, it's of the current year. 20% of last year's wage is added to last year. It's not 20% of 3 years from now wage. It's 20% of last year's wage. That's why the 12 is incorrect. Make sure you understand the difference here, because this is probably one of the most common mistakes done with wages or percentages past and present. Just wanted to hammer that hopefully one more time. Practice that multiple times over. We had operations again of sign numbers. This should be pretty easy. Addition, subtraction, multiplication, and division. If I have two positives, I should be able to know how to do those. If I have a positive and a negative, how does that come to play when I'm adding them, or I subtract, or I'm multiplying or dividing? Or if I got two negatives, how does that come into play? A real simple example of this would be adding two positives, adding a positive to a negative, adding a negative to a positive, adding two negatives. That's for just the addition. Of course, I could go with the subtraction, multiplication, and division. Hopefully pretty easy stuff for you. This is also a very common algebra problem. Again, just about every algebra test will have this. They'll give you some kind of algebraic expression, and they'll tell you to evaluate it, and they let you know what the X, Y, and Z are. You obviously got to put those in. Make sure that you use parentheses here. Otherwise, a lot of times you'll get into trouble. Then we also had properties of real numbers. We had a closure property. You may have to go back and check your notes on these because they might not be that familiar. I've got allergies happening, so I have to sneeze here. I apologize if I sneeze real quickly. It's from my spring allergies. We had closure property, we had commutative property, associative, distributive, identity, and inverse. We should be able to identify them. If I give you some steps where things are changing, you got to tell me what property, you should be able to do that. Again, it's important for grade school teachers to know these properties. They get built on every year, and you need to know where your particular year falls into place. Obviously, if you're teaching kindergarten, that's probably not a factor. But if you're teaching even second grade, commutative property, associative property come into play. We need to know those properties. Okay, we had solving first degree equations and inequalities. These, I think, for the most part, most people were really pretty good at. Here's a first degree equation because it's got an equal sign. You and I combine like terms and isolate the X. Hopefully not too difficult. This is one that is more frequently missed. It's an inequality. Notice that there's an inequality sign here. Remember, if you multiply or divide by a negative, you had to switch the sign. So that would be one that you'd have to be really careful about. Anticipate, a lot of algebra tests will give you that one. We had solving equations involving absolute value signs. Well, this one I can't go vertical here, but you would bring the 3 across. That would make it into 8. That means that your X could equal a positive or a negative 8, correct? Positive or a negative 8 could be put in there. Here, I would bring the 3 across and I get less than 8. Less than means it has to fall in between, if you remember, 8 and a negative 8. that was a less than. You could also have a greater than. Go back and check your notes on those. They're hopefully not too terribly difficult. There were multiple types of number value, probably should have a comma there, number value word problems. Again, there's many, many types of these. I'm just trying to remind you of one type. I have 14 coins, that would be the number part. 14 coins made up of nickels and dimes. Value would mean that they have a value of $1.05. How many of each coin do you have? That's an example of a number value. Number of things and value of things. Also a very common formula, rate times time equals distance. We had a lot of different types of word problems. Again, here's just one example. Emily runs at 7 miles per hour while Ken runs the same path at 5 miles per hour. How much time will it take for Emily to be 6 miles ahead of Ken? All using that rate times time equals distance. We had a whole bunch of different types of those kind of problems. We had consecutive integer problems like 3 consecutive odds added up to be whatever, or 4 consecutive evens, or 2 consecutive evens add up to be, or just consecutive integers add up to be, or they might, whatever the problem might ask for. Consecutive integer or odd integers or even integers. This is one area that I'm a little concerned about because historically this is an area that a lot of people struggle with, exponential rules. We had a whole bunch of rules. There was about 9 or 10 of them that we had. You can go back and check your notes. I'm sure you have them written down. But you had to be able to apply the rules. This would be a relatively simple one. We have coefficients -5 and 4, which would give me a coefficient of a -20. The exponents for the x's, when I'm multiplying across, I add them. 2 plus a -6 is a -4. The exponents of y are 3 and 1. I would get y to the 4th. Most people would probably get that one correct. This one goes to the next level. I have an entire expression squared. That means the -3 is squared, which will give me a 9. But x to the 5th times x to the 5th, or we can say square, we multiply those, so I get x to the 10th. Notice I didn't take -3 times 2 to get a -6. I took a -3 and squared it to get 9. But 5 I multiplied, -2 I'll multiply. This one would be frequently missed more often. Operations, again, addition, subtraction, polynomials. Could be monomials, could be binomials, could be trinomials. Here are some examples. Here I'm subtracting 2 binomials. Here I am multiplying right here a monomial, 7x, times a trinomial, -4x squared plus 3x plus 8. Then I'm adding that answer. Here I'm multiplying, that's multiplication. So binomial times a binomial, that would be our FOIL property. Here I am dividing. I would factor out a 2x from the numerator and cancel the 2x with the 2x. Again, this is the one maybe missed the most often. The way to simplify that one, of course, you would take a 2x out. Like that. And you would cancel the 2x's off and you would be left with plus 2x minus 6. Common mistake is people will just take 2 and cancel it with 4. They'll cancel x with x or something like that. That's one that's missed most often. Most of you, I think, would be pretty good here. We had factoring polynomials. I just tried to go a bunch of different types. There's more types than I have here. But we should be able to factor these. This would be conjugate factors, x plus 7, x minus 7. This would be the opposite of the FOIL distribution. Here is a more difficult FOIL reverse. tougher to one. This is the one that's so easy, it's oftentimes hard. That's why I put it there. This one here would factor into, you could take a 5x out and you'd be left with x minus 6. It's a lot of times people try to force this into a reverse FOIL, and it's not. It's just a monomial factored out. But be able to factor all of those types. I could ask you to reduce or multiply something like this. This one, if you were asked to reduce x minus 4, x plus 3, here you would have x minus 4, x minus 2. The x minus 4s cancel, and you're left with the x plus 3 over the x minus 2. Again, this was just a reduction, could be multiplying, could be adding. These were probably some challenging problems for a lot of students. I won't go super in depth here, but you should be able to take your skills of factoring and use it to either add, reduce, multiply, or whatever it might be. Again, it won't be the super hard ones, but it should be able to be done. Solving first degree and second degree equations involving fractions. Okay, this is, I think, oftentimes missed by a lot of students. Here's got fractions. It's first degree. X and x is going to be a first degree equation. Hopefully you remember what we're looking to do here is to multiply everything by the common denominator. Here's my problem. The common denominator of 4 and 8 and 12 is 24. So I would take everything times 24. That's how we would reduce that down. Here 4 goes into there 6 times. So 6 times those gives me 6x minus 18. 8 goes into there 3 times. 3 times 5 is 15. 12 goes into there twice. 2 times 7x is 14x. Then it's just a matter of solving a first degree equation. This was a first degree involving fractions. This is a second degree equation involving fractions. This one gets much more challenging when you end up working it out. Just going to copy it down here a moment first. I need to multiply by the common denominator. Common denominator here is going to be 5 times x plus 4 times x minus 4. 5 times x plus 4 times x minus 4. When I do that, I get rid of my fractions, but I get a second degree equation. Here, for example, the x plus 4s would cancel. So I would have 5 times 2 is 10. And I have 10 times x, 10 times minus 4. 10x minus 40. Here the 5s cancel. So I've got that product, x squared minus 16 times 3. Okay, so x squared minus 16 times 3 is 3x squared minus 48. Here the x minus 4s cancel. So you get 30 times x plus 4. 30x plus 120. You'll see now that you have a second degree equation. We bring everything over to one side. 30x brought over with the 10x will be a negative 20x. Here I've got negative 40 and negative 48. That's negative 88. Minus 120, I think, is a negative 208. And I'm doing this mentally, so if I miss add or subtract, I apologize. But you would do it hopefully correct. At this point, you could either try and factor. I would probably go right to my quadratic formula, negative b plus or minus square root of b squared minus 4ac all divided by 2a. It might have been factorable too, I don't know. The 3 would have been a little bit more difficult to factor. This you're guaranteed is going to work. But again, notice we started with fractions. We multiplied by the common denominator, simplified, and then used quadratic means to solve it. Also, I want to remind you, when you have these variables in the denominator, it's crucial to check your answers. Remember, x could not have been here, not equal to a -4. So if I get a -4 here, I don't use that as an answer. Here, the x could not be a +4. Either one of those two numbers would not be an option for us because it would make the denominator 0. All right? Another rate times time was a work problem. Here's an example. If Bill can paint the average size house in 3 days, Mary can paint that average size house in 4 days, how long would it take them if they worked together? Well, you remember you get the rate of Bill. Rate would be his work divided by the time. So his work was 1 house, time was 3 days. The rate of Mary, the rate is going to be work divided by time. So the rate of Mary, the work was 1 house divided by the time, 4 days. If they work together, they have a combined rate. So 1/3 plus 1/4, that's their combined rate times the time, will equal the work done. In this case, they want to work to get 1 house painted. And you would solve that for T. We also had variation problems. We had direct variation. Sometimes they say vary directly, indirect variations, or vary inversely. And we had word problems involving that, as well as expressions. You can go back and check your notes, but we had all different types. Obviously, I can't go to every last type, but probably be one of them in there at least. I haven't made the exam yet, but I'm going to guess I would put one of those in. Graphing linear equations and inequalities. We're getting more recent now. Here was a line. We could graph it either making a chart, or I could have gone with slope-intercept form to get that line. I could also have an inequality. Then we would be shading on one side or the other. This one would have been a dashed line, and I would have shaded above or below, depending on which side was the correct side to work on. This is hopefully getting a little more familiar to us. It's a little more recent. Another concept that's pretty important for algebra is to know the difference between relationships and functions. You should be able to tell that that is a function or that one's not a function, depending on multiple ways I can give that information. We had to evaluate functions. This again was pretty easy. If I give you some function, 3x minus 4, I could expect you could find f of 2, you could find f of 3, you could find f of 0, you could find f of a. That would be evaluating functions. This was a little tougher because you had to take a word problem and make a function by what you see. Again, it can give you an example, but everyone is different. It's not a same procedure. That's a little bit more of a challenge for you. We also had the slope formula, you remember. That's a little more recent, but that was the difference of the y's divided by the difference of the x's. We use that formula to find the slope between 2 points. We could also find the line between 2 points. We did that procedure, and we found lines that were parallel or perpendicular to another line. And they went through some point. Those are all different examples that use the slope formulas and use the lines. We did a lot of work with radicals in chapter 9. Some of them were perfect squares. Some of them we had to reduce down. So this one would have been a 7. Had it been a minus out front, we would have put minus. Had it been plus or minus, we would go plus or minus. This one would have been, I'll reduce it down right away, 2 radical 5. This one would have been 5i. This one would have been cube root of 8 raised to the 4th power, that would be 16. This is the cube root of 64, that would just be a straight 4. We did a lot of work with those radicals and fractional exponents. Finally, we started finishing up by solving second-degree equations. We could solve them. One like this could be factored. This one was not factorable. You'd have to use your quadratic formula. We also took those second-degree equations like this one, and we solved and graphed those, if you remember. This is where like both factors are positive, or one of each negative factor and a positive. It's what we did basically in 9.6, the very last lesson that we did on Monday. That winds up our review. Again, thank you for working so hard in this unusual setting. Remember to take some clean pieces of paper for your exam as well as your calculator. Maybe have a watch along that you can tell what time it is. But other than that, just prepare for the exam and we should be set to go. Thank you again for all your hard work. Have a good day.